All right, so the next part of vectors is when we're given limited information, yet we're still asked to calculate force in certain directions, right? And so here we have a problem that someone, let's say you, are going outside mowing your lawn and you are applying a force of 450 newtons at an angle of 56 with the ground, right? So you want to know exactly how much and in which direction are you pushing, or how much force are you putting in each direction. And so what we have to do is we have to break it up into what we call rectangular components, right? So kind of something what we're used to. And so from the information given, we can kind of map out, or we can kind of see this right triangle that we have here, right? And from this right triangle, we're given certain information. We're given a theta, and we're given this we'll call r, right? And so if we break it down as far as components, we can call this y, we can call this x, correct? And so we have information for this hypotenuse, and then we also have a theta. And so we're trying to figure out, okay, so what functions or what equations can I use that relate the information that I have, right? So I have a theta, and across my theta, across my angle of reference, is what we call the opposite side, right? We have information for the hypotenuse, and then we also need information for what we call the adjacent side. So we think back to trig and try to figure out, okay, well, what trig functions relates the opposite and the hypotenuse? And so that trig function is sine, right? So sine of theta is equal to the opposite side or the hypotenuse, and we relate it to the information that we have here. We have sine of 56 degrees is equal to the opposite side, which we are calling y, equal to the hypotenuse, which in this case is r, or in this case, sorry, it's 450 newtons. And so now if I wanted to find this y component, then I simply multiply the 450 over, and I get my y component is equal to 450 sine of 56 degrees, right? So all I got to do is put in the calculator, and I get my vertical component, right? So I get the amount of force that I'm pushing down on this lawnmower with. And similar, we approach the x, or the adjacent side. So again, we're trying to figure out, okay, which trig function relates adjacent in the hypotenuse, because that's what we have, and that is cosine theta. So cosine theta is equal to my adjacent over the hypotenuse. And so if I relate it to the information I have here, I have cosine of 56 is equal to the adjacent side, which I'm calling x, over the hypotenuse, which is 450. And once again, if I want to solve for x, which is a component version, I get 450 newtons times cosine of 56. And again, all I got to do is put that in the calculator, and we get my component version of that, right? And so it's helpful because once we start adding vectors, like once we start adding more than one vector together, we have what we call resulting vectors that we have to find all this information for. And it's good to be able to break down stuff into its component version, because all we got to do is add the components. And so let's look at one more problem, right? So here's another problem. If I wanted to find the components for it, we already see the right triangle here, or we should see the right triangle. What we have to do is follow the same concept, right? So the goal is here is, can we create a right triangle? And if so, can we find this angle so that we have our angle of reference? So that becomes the opposite side, this becomes the adjacent side, and then this becomes the hypotenuse. And then from there, all the problems are basically going to be the same, right? So y is going to be equal to your hypotenuse, which is 50. And then since we're talking about y, we want sine of 60, and the same for x. So x would be equal to your hypotenuse, which is 50, times not sine, cosine of 60. And then we go as follows.